Hey everybody. Okay, third section of the chapter. Okay, arcs and chords. It's important that you open up the notes, okay, and look at these pages. This material is there, so you can look at it a little bit more. There's a little bit of information here, some of it repetitive, okay, but you do have to know it, okay? You've also got your PowerPoint there. Now, the first three theorems are all related. They deal with a drawing similar to this, okay? Talks about a radius or a diameter, remember, we'll just continue through to be the diameter, okay? That is perpendicular to a chord. The first theorem says, in a circle, a radius that is perpendicular to a chord bisects the chord, cuts it into two equal parts. Second, in a circle, a radius that bisects a chord is perpendicular to the chord. Converse, okay, if then, remember those? In a circle, the perpendicular bisector cuts it in half and is perpendicular to it, okay, remember that one, okay, passes through the center of the circle, which means it's a radius. That's where we're at. So those three go together. We're going to use them to solve problems. I want you to think about something here. Look at this. QC, QB, QA are each radius of the circle. So they're all going to be the same. So if you have QB, okay, QA is the same length and can create a right triangle. We know how to solve right triangles. Okay, that's why it's important. Okay? Next, in a circle or congruent circles, like two tires, okay? Congruent chords form congruent arcs. Okay, you will also see the term intercepts. When a chord touches a circle, remember its endpoints are on the circle. The arc that is formed or created is said to be intercepted. That's it. Okay? So these all go together. Excuse me. If I have congruent chords, their arcs are equal and they are the same distance from the center of the circle. Okay? If I have two equal arcs, then the chords that intercept them are congruent and they are equidistant, same distance from the center of the circle. If I have two chords which are equidistant from the center of the circle, then they form congruent arcs. Okay? So this is kind of what you're going to see on the notes. This is it in living color. Okay? Okay, let's go do some problems to get you started a little bit to see how this comes into play. Okay, so here's our first couple. Okay? Remember our marks that tell us what's equal and what's not. All we're doing through these four are finding the value of x. Okay, so in this one, because this arc is equal to this arc, that means this chord has to be congruent or equal to that chord. That's all we're going to do to set up our problem. 4x plus 10 equals 38. Okay, and there's our first one right there. Okay, excuse me for a minute. Don't mind me, I just leave stuff laying around. Okay, number 2 here. This chord is equal to this chord, which means this arc is equal to this arc. And they give us this arc. Okay, here's where we become detectives. If these are equal lengths, that means this arc and this arc must be equal. So what I'm looking at is x, x, and 70. Now I've covered the entire circle. So I'm going to look at them. Okay, so x plus 70 equals 360. Okay, we're going to go with the obvious. Okay, there we go. Just for the sake of argument, I figured it'd probably be a good idea to bring the right notes. Hey. Okay, so you found the x there. Now, a couple more. Here, we may not see the marks. We may have actual numbers. Well, if those arcs are the same measure, 109, 109, that tells me that these two chords are the same length. Okay? Okay? That's about all we're dealing with. Now, once I'm told I have congruent circles, remember each of those theorems had in the same or incongruent circles. So if circles are congruent, they're identical. Okay? So that tells me that these chords are, because they're equal, their lengths have to be equal. Okay? Yeah, sometimes it's that simple. Okay, pretty straightforward. Okay, let's look at a couple that may or may not give us a little more trouble. Let's look at this. Okay, on this particular one, we've got a single problem. Okay, so when you see information like this where they just give you the lengths or such, and then multiple questions, it's not going to change. It's one big problem where they've created, in this case, 4 separate ones out of it. There are other problems that will change the information from problem to problem. In those, you do not carry information over and over. Okay? So let's look. The radius of circle N is 18. Okay. If this is 18, that means NG is also 18. Okay, should we need that? Okay, we know that NK is 9, and the measure of DE is 120. Okay, remember, this is bisected the chord and the arc. So I have 60 degrees here, 60 degrees here. So that's all the information I know, except one thing. Remember central angles? If this is 60, that's 60. And what else can we infer from that? Wait, 60 and 90, that means this has to be 30. And there's our old friend, the 30, 60, 90. Friend, nemesis, that's up to you. Okay? So that's what we've got. So now we can find our information. The measure of GE. We know that. The measure of angle HNE. the measure of angle HEN. The measure of HN. It's got to be the same as NK. And there we have it. Okay? So, there's that one. Next one. Okay? Once again, let me... Okay. In circle P, QR is 7x minus 20, and TS is 3x. We are given the fact they are equidistant from the center, which means those chords are equal in length. So that equals that. There's your equation. There's your answer. Okay. Once again, don't worry because you will get the stills on this. And our last example here today. Okay. In the circle with center at K, JL, the chord, remember this is where the symbols are important. Make sure you're seeing chords are equal, arcs are equal. So, JL and LM are equal to each other. Okay? So, KN and KP. Well, if the chords are equal in length, they are the same distance from the center of the circle. Okay? So that means this and this must be equal to each other. Okay. Solve the algebra equation. Okay? And you're done. That's what we're doing today. Okay? Once again, don't let the diagrams throw you. Use your information. Look what one piece of information tells you about another piece, and that's usually where you're going to find your equations. Okay? Good luck.